All right, so again, the thing I really like about the way that I tend to solve inequalities is that it is a universal solving method. There's always shortcuts, but you can learn those later. And if you know the universal method, you'll always have a way to solve things. So I'm going to solve this the same way I normally do. I'm going to find my critical values by looking at the equality. All right, so I'm going to go ahead and solve this like I would any quadratic. First setting one of the sides equal to 0, then factoring. Once I've factored, I'm going to use the zero product property to find those zeros. Okay, again, just if x plus 5 is equal to 0, then 0 times x minus 2 will be 0, and vice versa. Here I get x is equal to -5, and here I get that x is equal to 2. Okay, and now I have my two critical values, so I'm going to look at the different test intervals I might have. I like to graph out those critical values first, so I'll do that now. Okay, and so I have three possible intervals. I did use a greater than or equal to sign in my original equation, so I'm going to be using brackets the whole way through. So I could have the interval to the left here or the interval to the right. And I am making those the same color on purpose. You can maybe think about why I might do that. And then it could be the interval in the middle here. And so I just need to come up with test intervals for those different intervals. I'm sorry, test values for those different intervals. So that first interval goes from from negative infinity all the way to the left until I hit -5. Okay, and then the last one goes from 2 until I hit positive infinity, and then I have that middle interval that goes from -5 to 2. Right? And now I just need to come up with test values, so I'm going to pick a value in each one of those intervals. So now the last thing to do is to just test those values. So I'm going to take my original inequality and plug in my test values. So it looks like that first interval worked. Let's try the same with x equals 0. Well, -2 is not greater than or equal to 8, so I know that this interval is no good. And then I test my last interval. And that seems to have worked just fine. So those are my two solution intervals. One of the things I want to point out is that if you're a little more comfortable with graphing, and as we start to understand these functions a little more, I already knew that that middle one was not going to work. And here's how I knew. Well, I know that this is a parabola right here, right? And so I've got a parabola, and I basically have a few different options. I'm wanting to know when that parabola is going to be above the 8, y equals, so that would be like the y2 equals 8, right? That's a horizontal line. Okay, so if that's the case, then I really only have a few different options. One, my horizontal line could be down here underneath my parabola, in which case I would have no solutions. My parabola could just kiss the bottom of it, in which case I would have one solution, but then I would only have, in both those cases, I wouldn't have the two critical values here. So really, the only possibility here is that my horizontal y2 is intersecting the parabola in some way like this. Well, if that's the case, then I know my solutions have to be over here on the ends where my parabola is above that purple line or pink line. Well, if that's the case, then I know my solution set has to look like the OR graph. So in reality, as soon as I double check to make sure that these intervals work, I really almost don't even need to check this. It's not a bad idea to double check, but I can feel real confident my answer is good because I'm starting to understand how these functions behave. And again, we'll talk more about graphing in the next unit, but start to try to think about these things as these well-rounded, predictable systems because that's what they are.